Imagine you're an astronomer working the night shift at a Hawaiian observatory. It's October 19th, 2017. You're checking routine asteroid data when your screen shows something impossible. An object moving so fast it breaks every model you've ever learned. Your first thought: the equipment is malfunctioning. Your second thought: someone made a calculation error. This thing isn't from here. Robert Warwick didn't sleep for the next 48 hours. He'd just discovered the first confirmed object from another star system to visit ours. Not a radio signal, not a flash of light, but an actual physical piece of another solar system tumbling through our cosmic neighborhood. The asteroid hunting telescope had caught something it was never designed to find: a messenger from another star. The object was already leaving. Like catching a glimpse of a rare bird just as it flies away, humanity's first interstellar visitor was racing toward the exit, and we'd almost missed it entirely. If the Pan-STARRS telescope had been pointed somewhere else that night, if Warwick had been sick, if clouds had covered Hawaii, Oumuamua would have passed through unnoticed, like countless others before it. What followed was the most frantic few weeks in modern astronomy. Every major telescope on Earth abandoned its scheduled observations. Space agencies redirected satellites. Graduate students dropped their research. The entire global astronomical community pivoted to study one tumbling, reddish, cigar-shaped object no bigger than a skyscraper. We were trying to read an entire encyclopedia while it burned. The data that came back defied explanation. Oumuamua wasn't just passing through, it was misbehaving. The object was accelerating away from the sun faster than gravity alone could explain, but it showed no comet tail, no outgassing, no visible means of propulsion. It tumbled every 7.3 hours, its brightness varying by a factor of 10, suggesting a shape so elongated that nothing like it exists in our solar system. Then came the question that changed everything. What if it's artificial? Harvard's astronomy department chair, Avi Loeb, didn't whisper this in dark corners. He published it in the Astrophysical Journal. Could Oumuamua be a light sail pushed by solar radiation? Could it be a defunct piece of alien technology, tumbling dead through space like a derelict ship? The scientific community erupted in debate, not because the idea was absurd, but because the data couldn't definitively rule it out. SETI turned their most sensitive radio telescopes toward Oumuamua. For days, they listened across billions of frequencies, searching for any whisper of artificial transmission. The result? Silence. But silence doesn't mean natural. A dead probe wouldn't broadcast any more than a dead satellite would. The mystery deepened with every non-detection. By December 2017, Oumuamua had faded beyond our ability to see it. In 6 weeks, we'd gone from discovery to loss. The first known interstellar object had given us more questions than answers, then vanished into the dark, continuing a journey that began before Earth had life. But Oumuamua had changed something fundamental. It proved that objects from other star systems pass through ours. The space between stars wasn't empty, it was a highway. And if one object could be detected with our limited technology, how many were we missing? The answer, when calculated, was staggering. At any given moment, there should be thousands of interstellar objects within the orbit of Neptune. The hunt intensified. Every anomalous orbit was scrutinized. Every fast-moving object was checked and rechecked. Astronomers knew that Oumuamua couldn't be unique. The galaxy doesn't produce one-off events. If one interstellar object had visited, Others would follow. On August 30th, 2019, Gennady Borisov, an amateur astronomer in Crimea, found the second. Using a telescope he built himself, Borisov spotted a fuzzy object that would revolutionize our understanding once again. Unlike Oumuamua's mysterious nature, 2I/Borisov was clearly a comet. Tail, outgassing, the works. But its chemical composition was alien. Too much carbon monoxide, strange ratios of isotopes, evidence of formation in conditions that don't exist in our solar system.